Compression reduces the size of a file, and there are 3 reasons to want that, each worth naming separately because questions ask for them. Storage. More files fit in the same space. Transmission. A smaller file travels faster and uses less bandwidth, which matters for streaming and for anyone on a limited data allowance. And download time, directly proportional to size, so halving a file halves the weight. The last lesson gave the motivation with real numbers. 30 megabytes for one uncompressed song against 3 or 4 for an MP3. Compression is the difference between a music library that fits on a phone and one that does not. There are 2 kinds and the difference is absolute. Lossless compression reduces the file size while keeping every single bit of the original data. Decompress it and you get back exactly what you started with, byte for byte. Lossy compression achieves a much greater reduction by permanently discarding some data, and that data cannot be recovered. Decompress a lossy file and you get an approximation, not the original. So the question that decides which to use is simple. Can this data survive being changed? For a text document, a spreadsheet, a program, or a database, the answer is no. Losing one character of a program breaks it, and losing a digit from a bank record is unacceptable. Those must be lossless. For a photograph, music, or video, small changes the human eye or ear cannot detect are perfectly acceptable, so lossy is used, and the savings are far larger. Run-length encoding is the lossless method the syllabus expects you to be able to do by hand, so let us work the example on the page. The data is AAAAABBBCCCDDDDD, 16 characters. RLE looks for consecutive repeating values and stores each run as a count, followed by the value. 5A's becomes 5A, 3B's becomes 3B, 3C's becomes 3C, 5D's becomes 5D, so the compressed form is 5A, 3B, 3C, 5D, 8 characters where there were 16. Now the arithmetic the exam wants. Original, 16 characters at 1 byte each is 16 bytes. Compressed, 8 characters is 8 bytes. The saving is 8 bytes out of 16, which is 50%. And the compression ratio is 16 to 8, which simplifies to 2 to 1. Now the crucial part, which the page does not show and which questions do test. Take the string A, B, C, D, E, F, G, H, also 8 characters, but with no repetition at all. RLE encodes it as 1A, 1B, 1C, 1D, 1E, 1F, 1G, 1H, 16 characters where there were 8. The file has doubled in size. So run-length encoding only helps when the data actually contains runs, and on data that does not repeat it makes things worse. That is why RLE suits simple graphics with large areas of flat color and is useless on a photograph where almost no 2 adjacent pixels are identical. Lossy compression works by deciding what a person will not notice and throwing it away. In images, that means reducing the color depth so that similar shades become one shade and discarding fine detail, which is why a heavily compressed JPEG shows blocky patches around sharp edges. In audio, it means removing frequencies outside the range of human hearing and removing quiet sounds masked by louder ones happening at the same instant, which is a real property of how hearing works. In video, it means both of those, plus storing only what changed between frames rather than every frame in full. Notice the common principle. Lossy compression is built on a model of human perception, and the data it removes is chosen because people are bad at noticing its absence. That is also its limitation. Repeatedly compressing an already compressed file degrades it further each time, because each pass discards more, and nothing that was discarded ever comes back. So, the comparison. Original quality, lossy, loses it permanently, lossless keeps it exactly. File size reduction, lossy is much greater, often 90% or more. Lossless is more modest, typically 10 to 50% depending on how repetitive the data is. Reversible, lossy no, lossless yes. And typical uses. Lossy for JPEG images, MP3 audio and streamed video. lossless for zip archives, PNG images, text, spreadsheets, and executable programs. When a question gives you a scenario, decide on one question. Does the data have to come back identical? A medical scan used for diagnosis, a legal document, a program, a bank record. Lossless, and say why, because altering the data would change its meaning or break it. A photograph on a website, background music, a video call, lossy, justified on the size reduction and on the loss being imperceptible. 4 things to take into the exam. First, define lossless as reducing size while keeping all the original data, and lossy as reducing size by permanently removing data. The word permanently is what earns the mark. Second, be able to perform run-length encoding by hand and calculate the saving, both as a number of bytes and as a percentage. Third, know that RLE can increase the file size when the data does not repeat, because that is the point most candidates have never considered, and it demonstrates you understand the method rather than the recipe. And fourth, when choosing for a scenario, justify from whether the data must be recovered exactly. Saying lossless is better earns nothing. Saying a program must be lossless because changing any byte would stop it running earns the mark. One last point that ties this topic to the rest of the course. Compression is why streaming works at all. An uncompressed high-definition video runs to roughly a gigabyte per minute, which no ordinary connection could carry in real time. Compressed, it is a small fraction of that, and the packet switching from topic 2 delivers it, while the buffer from topic 4 covers the gaps. Compression, packets, and buffers are 3 separate parts of the syllabus, and watching a video uses all 3 at once.